Hey, thanks for having me. My name's Albert Otten. I'm an engineer at the trade desk. I'm coming to you from San Marcos, Texas, and I want to talk about evictions and storage and you. I have a story to tell you about Aerospike and evictions. We ran out of storage. A couple of years ago, we had a deduplication namespace. It ran out of space. We used this to help us prevent duplicate feedback from being recorded, and this helps us clean up our billing system. So when we see something, we don't want to end up billing you twice for it or the publisher twice for it. The business requirement was that we store this cache for 8 hours, but it got to the point where we were only storing this for 1 hour. This led to problems with duplicate feedback getting recorded. This led to escalations where we were not having our billing system in order. And we realized that this was caused by evictions. The immediate answer was we had to go and immediately add storage and make enough room so that we weren't evicting data. And we had service restored shortly. But later on, a coworker named Aaron posed a question of why don't we just keep it as long as possible? So we need 8 hours. That's a business requirement. But 10 hours might be good. 24 hours might be even better. So we changed our design. We are out of storage all the time, and we like it. 53% of our servers are out of space. 73% of namespaces are designed to run out of space. And on the left here, we have the number of records evicted per day. More on the team. I am on the NoSQL team at the trade desk with 3 other coworkers. These are our professional headshots. Yes, I work with a dog. He's very cool. I have over a decade of experience working with Aerospike. Haven't dabbled much with the other NoSQL solutions. Prior to that, mostly sysadmin experience. We get to work with Aerospike, Mongo, and Scylla, Cassandra. We've worked with a lot of those technologies, and that's what we do at the trade desk. So I want to talk about what happens when you run out of storage in a database. As far as I know, you have to pick one of these. You can fault and go into read-only mode, or you can delete data in some kind of way. So we normally like the second option here lately, and Aerospike has a mechanism called evictions that helps us do that automatically. Read-only is good for options where we have a source of truth, and faulting going on to read-only mode is preferable over deleting the data, but that has other problems and availability problems it causes. Right, so we choose deletion through evictions. So I want to talk about what evictions are. Evictions are simply early expirations. Instead of the data sticking around for the amount of time that you set, it might be cut off a little short. So I have some visual representations to help illustrate that here coming up. This will be the next 5 slides or so. This is distribution of record age. Get my laser pointer out here. Laser pointer. So in this chart, we have today. Today, let's say we wrote 9 records. They appear to be lasting for about 10 days or so. So the records that we wrote 10 days ago are expiring out. Today, though, they're all fresh. Yesterday, I wrote 14 records and so on and so forth. So this is a namespace or a use case where we're just storing all of our data. with a 10-day TTL. The conversation of what happens when we run out of storage is helped with evictions. So with this chart, the question was, what if we just moved this 10 days backwards? What if we just pushed the time when it expired to 7 days or 6 days or 5 days? And that's exactly what expiration or eviction does. So as we run out of storage, we'll start throwing that data away a little bit earlier and earlier. So if you wrote some records today, they might only live or stick around for 5 days instead of the planned 10 days. The new data still coming in the system, still being touched, is still there, still fresh. If it gets updated again, it gets refreshed. So as long as this is within our business requirements, as long as it's okay to keep the data for 4 days or more, we're still within our requirements. For us, recent data is the most valuable. Evictions pair really well with an LRU cache. For example, with Aerospike 7.1 release, we have LRU cache implementation. For AdTech, a lot of our business is all about recency. If someone's recently interested in something, if someone recently clicked on something, so much of the data is about recency. So many of our use cases and data stores rely a lot more on recency, and the old data is not as valuable. So we made some trade-offs, and that led to some exciting new problems. As the business grows, we have new ideas, things change, things go wrong. We have all these requirements being thrown at us. We have so many deployments. We need to still be able to be strategic. What I mean by that is, how do we know if 3 times more records is feasible? We're full. We don't have storage. If we're always full, we can't answer that question, right? Similarly, we have organic growth throughout the business, and some uses that's 20% year over year. Sometimes we have a new innovation or a new probabilistic data set that we want to attach to some existing data, and those are going to make them grow by 4 times. We don't have a way to understand what that's going to do, and this has bit us really bad. Going back to that previous graph we have, where the evictions were creeping left, getting closer and closer to our most recent day. This can keep going, and it can get out of control. And this happened to us, where we weren't storing data for more than a few hours. And we learned the hard way. So we had to come up with some solutions. How do we know if we've gone too far? Well, that's what I'm calling the bare minimum. With Aerospike, we get a metric called evict TTL that'll be exporting the TTL of the records that are being thrown out. So if the data was supposed to expire in an hour and it got evicted instead of expiring, your evict TTL would be 1 hour. In this example, we have our evict TTL at 8.92 hours. That means that data should have lasted in the system another 8.92 hours. And we tossed it out 8.92 hours early. This is nice because it allows us to be reactive. We can now know if we've gone too far. But this has problems. You see this flat line, I may have already figured out. This metric doesn't update all the time. This metric only updates when evictions are happening. So once we fixed this issue or got capacity back, whatever, it just continued exporting that same number. So we had to pair this with some kind of metric or function of detecting changes. So the eviction TTL is too high and it's changing. So that's a little problematic. This is also reactive. This isn't strategic. This is something happened and we're in the bad zone. We can get an early warning, sure, but this doesn't let us understand what the impact of losing half of our servers is or growing the record size by 50%, whatever. There's no projection. It's just the now. And what I want is I want heat maps. I want to be able to see the distribution. I want to be able to define as many buckets as I want. I want to understand how those buckets look at various times of the day. I also want quantiles. If I have the 50th percentile of the data, this example, 4.7 is the 50th percentile for the TTL. So more than half the data is at 4.7 TTL or below. And I want both of these things to help me be more strategic. So we wrote the Aerospike TTL exporter. This is a Prometheus exporter, runs kind of as a sidecar, a process running on the side. You could run it on a dedicated server if you want. This is written in Golang, and it randomly samples Aerospike that's configurable, and it creates a histogram of how many bytes are falling in each TTL bucket and how many records are falling in each TTL bucket. It's totally configurable. The resolution is configurable. This uses the Prometheus histogram functions, the observe function, to accomplish that, along with using Aerospike scans. And for getting the bytes, we're using a metadata operation where we ask the API to give us the bytes per record instead of actually pulling them off disk. So this is all very light, read only, no IO. It's not actually pulling any records back into it. So I wanted to show you, just to drive this point home, a demo. One of the questions we get all the time, what if we grew our record size by 50%? We're full, so we'll still be full is the answer, but that's not a good answer. I want to show you the setup first. Within Aerospike, we can set a hard defined max used percent, kind of using the high water mark. In this example, we were using 36% of our disk, and this is production. I lowered it to 18% and threw out a bunch of data. That's fine. We do it all the time. This was just to create a slide for you guys. And this blue zone is the servers selecting and throwing that data out. It's throttled. We don't want to be deleting data too fast or be moving the data around too fast. It could impact business. Well, we don't want to prioritize deleting data over accepting writes or accepting reads. So this is our time frame. So around 1745, our storage halved, or this could simulate records growing or 2xing. I guess that's not 50%, 100%. So in this example, we're doubling our record size or halving our storage size. That's however you want to look at it. The projection we got from the exporter was 8.95 hours. With this Prometheus histogram, we can ask for the 50th percentile quantile of the data, and it will tell us what TTL bucket that would fall in. So at 1745, before we start throwing out any of that data, before we threw away half of our data was at around 8.95 hours or below, remaining on their TTL. And then we halved it, and you can see the exporter is detecting all those changes and producing a new prediction. So we halved it around 17:45, right before it started throwing out data as 8.95 hours, and then we get to see the result. The result was we threw away data until we got to 8.92 hours. So before we did these changes, we were throwing data out around 2.7 hours early. And after we threw our data out, after we lost half of our storage or doubled our record size, however you want to put it, we were at 8.92 hours. And we were able to project that using the 50th percentile of TTL based off of bytes. So in summary, evictions can be okay, but you need to have a plan. You need to monitor the TTL. You need to be able to be reactive and strategic. You need to be able to project and do capacity planning and answer those tough questions. What if we have half of the servers? What if the use case doubles? What if we add a new bin, a new column, whatever? On the Aerospike side, you can download that exporter. That'll give you the extra monitoring with the histograms to generate heat maps and quantiles. And this type of practice, storing data until you have evictions, planning to have evictions, this pairs really well with LRU. We've recently used caching with dedupe and other caches. So I encourage you to look at that because that will let you use 100% of your storage. 100% of your hardware is a great thing to be able to use, especially if it has a benefit to your business. Thanks.